You've seen it everywhere. On t-shirts, in movies, E equals mc². It's become the very symbol of genius. But, the clean, simple beauty of that little equation hides a seriously complex, kind of messy, and absolutely brilliant story. And that's the story we're going to unpack today.
Because let's be honest, while we all recognize it, very few of us have any idea how Albert Einstein actually got there. It wasn't some sudden flash of inspiration. No, it was more like an epic quest, a detective story where the clues were all hidden in the language of mathematics. And here's the secret. E equals mc² is really just the grand finale. It's the peak of a mountain built on 5 other much lesser-known ideas. Think of them like the lost blueprints Einstein had to draft before he could build his masterpiece. And today, we're going to find them. All right, so our journey starts back in the early 1900s. And you got to understand, at this point, physics was in the middle of a major crisis. There was this fundamental conflict that was brewing, and it was setting the stage for a complete revolution. For more than 200 years, everybody just assumed Isaac Newton had it all figured out. Mass was mass, time ticked away at the same pace for everyone, and space was just space. But there was this one nagging problem: light. No matter how fast you were moving towards it or away from it, it always traveled at the exact same speed. And that just completely broke Newton's rules. So Einstein comes along with this totally wild idea. He says, what if we've got it all backwards? What if the speed of light is the only thing in the universe that's constant, and everything else we thought was fixed, time, space, even mass, is actually flexible? So to solve this puzzle, Einstein basically had to invent a whole new set of tools for physics. You could call it a relativistic toolkit. He had to completely rewrite the definitions of things we thought we understood, like momentum and energy, for this new universe where the speed of light is the ultimate speed limit.
Okay, so let's check out our first blueprint, relativistic-momentum. Now, in the old Newtonian world, if you wanted something to go faster, you just pushed it harder. Simple. But Einstein realized nothing can go faster than light. So his new formula showed something amazing. As an object gets closer and closer to light speed, its momentum just shoots up towards infinity. It gets harder and harder and harder to push.
And this isn't just theory, We actually see this happen for real. In giant particle accelerators, scientists blast protons with insane amounts of energy to get them moving at 99.99% the speed of light. And just like the math predicted, the particles become unbelievably stubborn. They just resist going any faster. And that was a huge clue. All that energy being pumped in wasn't just adding speed anymore. It had to be going somewhere else. And that question, where is the energy going, leads us directly to the second blueprint. Einstein came up with a new formula for kinetic energy, which is the energy of motion. And hidden inside this new, more complicated equation was an absolute bombshell. It showed that an object's total energy wasn't just its motion. No, it was its motion plus something else, an energy it has even when it's sitting perfectly still. He discovered this inherent rest energy. Okay, this brings us to our third pillar. And this is where things get really weird. So hang on. It's the idea that an object's mass isn't a fixed thing. I mean, this just flew in the face of centuries of science. Everyone thought mass was just stuff, permanent, unchangeable matter. But Einstein proposed that as you pour energy into an object, its mass actually gets bigger. What this really means is that mass and energy are basically two sides of the same coin. Mass is just congealed energy. So here's a wild thought. When you heat up a cup of tea, you're adding energy to it, right? Well, that means you're also adding a tiny, infinitesimally small amount of mass. The line between what's stuff and what's energy was starting to get really blurry. So Einstein's got these 3 really complex new ideas about momentum, energy, and mass, all swirling around. Now, he needed some way to connect them all. He needed a bridge. The next 2 blueprints are these beautiful mathematical tools he used to link all these messy, complicated pieces into one simple, powerful truth. So this fourth pillar, wow. It's so fundamental, so perfectly elegant that some people call it the Pythagorean theorem of the universe. And that's because it connects the most important qualities of any object in one incredibly beautiful relationship.
And here it is. E² equals PC² plus mc² squared. Now, I know, that looks a bit intimidating, but don't worry about the symbols. What it does is actually pretty simple.
It creates this kind of cosmic right-angled triangle where an object's total energy is perfectly related to its momentum and its basic rest mass. This equation right here, this is the real hidden key to everything.
And from this one master equation, we can see exactly how the famous one just pops out. So let's just think about an object that's not moving. It's at rest. Well, what does that mean? It means its momentum, that's the p, is 0. So that whole first part of the equation, the pc² bit, it just vanishes. It becomes 0. So now we're left with e² equals mc² squared. You just take the square root of both sides and boom, there it is. E equals mc². It wasn't pulled out of thin air. It was hiding inside this deeper, more complete law the whole time.
But Einstein had one last crucial step. He needed a reality check. He had to prove that his wild new ideas about physics didn't totally break the old physics that, works perfectly fine when you're just throwing a baseball. For this, he used a nifty mathematical tool called a Taylor expansion. It's basically a way to simplify a super complex equation to see how it acts under normal, everyday conditions. And what he showed was just brilliant. He proved that if you take his super complicated relativistic formulas and apply them to things moving at everyday speeds, like a car or a person walking, all the complicated new parts basically cancel themselves out, and you're left with Newton's good old classic formulas. So this wasn't about replacing Newton, it was an upgrade. It was a more complete picture of how the universe works at every speed, from a snail's pace to the speed of light.
And so, with all 5 of these pillars finally in place, the stage was set for the grand synthesis. This was the moment where all the complexity, all the messy blueprints, all the hard work was about to resolve into a single, perfect, and profound statement.
I mean, just think about the journey we've been on. From those stubborn particles that refuse to be pushed faster, to the energy hiding inside a silent, sleeping atom, all the way to the Pythagorean theorem of the cosmos itself. All of that intellectual struggle, wrestling with some of the hardest math imaginable, it was all about to pay off.
He had done it. He had wrestled all of that mind-bending complexity into breathtaking simplicity. He had uncovered a fundamental truth about the fabric of reality itself, that energy and mass are not two different things. They are one and the same, forever linked by the speed of light squared. And look, this isn't just some abstract idea for a blackboard. This single equation underpins our entire modern world. It's the engine behind nuclear power. It's the reason stars shine in the night sky. It's why those giant particle accelerators work, and it's even a crucial part of why the GPS in your phone can tell you where you are with such crazy accuracy. So the next time you see that iconic formula, E equals mc², I hope you don't just see a symbol of some far-off genius. I hope you see the story behind it, the incredible journey through 5 lost blueprints that ultimately revealed one of the deepest, most beautiful secrets of our universe, that the very stuff we're all made of is nothing less than frozen light.